go from e to 2x plus 2x minus 1 over x dx. Can anyone help with this? Which function prime is e to 2x?
E to 2x over
Excellent.
2. Sorry.
Exactly. Awesome. Plus, which function prime is x? Which function I differentiate to get x? Anyone?
X squared over 2.
Exactly, thank you. So I'll simplify. Minus, which function prime is 1 over x? There is a function with that we differentiate and we get 1 over x.
ln x.
Very good. Don't forget to write the absolute value of x. Awesome. Plus, of course, a constant c. The integral from number 1 is called I just need the name of this. Notice that this symbol alone does not exist without this. The function could be 1, but once I have this symbol, it has to follow and the function, and it has to follow dx. If x is t, then it has to be dt. If instead of x I have w, then I have dw. So the integral from above is called the how do we call this symbol?
The sum.
Yes, but I want, so I didn't want to put the whole name here. So it's the indefinite. The reason I emphasize this is because there are 2 types. We're going to talk about the second type today. This is one of them. Indefinite integral. Or the most what? General. Yes, the most general antiderivative. So it's either the indefinite integral or the most general antiderivative. And of course, this result is a family of functions. Many, infinite, right? Because C can be anything. Family of functions. When I differentiate this, I must get this. Otherwise, this is wrong. When I differentiate this, I check by getting this. Let's check. E to 2x prime, it's e to 2x times 2, and I simplify and I get this. X squared prime is 2x. Natural log x, an absolute value, is 1 over x with minus in front. C prime is 0. Number 3, we can or we cannot check the result of an indefinite integral. We can or we cannot.
Okay.
Yes, I just said it. Exactly. How can I? I take this, I differentiate it to get that. I can always check. An indefinite integral, the answer of an indefinite integral, I can always check. How? If we can, yes, we can. If we can, it is done by what process is this?
Differentiate.
Thank you very much. Exactly. It's done by differentiation. Awesome. The area under the graph of marginal profit for, between, I should say, same thing, between 0 and 1,000 units represents the area under the graph of the marginal profit function between total profit for 1,000 units. Awesome. Excellent. This is the core of our discussion from last time. The technique, it's important, but this is the core. I can determine an indefinite integral. It's a family of functions. I can always check. What else? The area under a graph, if I manage to determine it, even if it's approximate or exact, it will give us approximate total profit or exact total profit if I determine it exactly. Awesome. Between this and this, I have to have limitations. Good. Excellent. Thank you so much. Okay, so we are back here. I want to go back and finish this problem. But maybe I should just start it from the beginning, so it's better if I start it from the beginning. And this was, I'm going to share my screen right now. Okay, and this is chapter 4, and this is 4.2, and we are on page 402. O2. Okay, so we were looking at problem 19. Was it 19? Yes, 19. 19 part A on 402. So let's count again. 1, 2, 3, 4, 5, 6. So the area left 6. We realize that the base of each rectangle is 1. So I should put it in front, but since it's 1, I don't need to do anything. Then you told me f of 1 plus f of 2 plus f of 3, and so on and so forth. So this is f of 1, f of 2, f of 3, f of 4, f of 5, f of 6. And the function is given to us 1 over x squared. So f of x equals 1 over x squared. Okay. It's not a difficult situation, right? Because this 1 over 1 squared is 1. This 1 over 4. This is 1 over 9. This is 1 over 16. This is 1 over 25. And this is 1 over 36. I just have to add these numbers. And I'm going to do it quickly with a calculator. So, one plus 1/4, that's 1.25. I know that already, plus 1 over 9, plus 1 over 16, plus 1 over 25, and finally plus 1 over 36. Good. So I should be able to change this into a fraction. Ugly one. That's why I didn't want to do it by hand. So 5369 over 3600, and I'll say approximately 1.49. So the area, where is my book? So the area under the graph of 1 over x squared, this is the graph 1 over x squared, between 1 and 7, we see it's an overestimate, guaranteed. So we got approximately 1.49 units squared. Since we don't have the measurement units, a specific measurement unit, then we can just say 1.49. Any questions? Do you feel like working on another problem like this, with approximating the area under a graph?
Yes, please.
Okay, very good. So let's look at 21. 21, we are given f of x equals 0.01 x to the fourth minus 1.44 x squared plus 60. They're giving us the interval 2, 10, and they want us to use 4 subintervals. Okay. So first of all, I have to look at this interval, 2 to 10, 2 to 10. And I have to divvy it up in 4, exactly 4 subintervals. And I just did. Okay. So this width is normally called delta x, and it will always be 10 minus 2 divided by the number of subintervals, which is 4. 10 minus 2 is 8. 8 divided by 4 is 2, which we know. So this is 4, this is 6, and this is 8. Now, let's choose if they don't tell us. Approximate the area under the graph of over the interval. It doesn't say. It means that we are allowed to choose. Do we want to choose the leftmost point or the rightmost point? So here's the difference. If I use the leftmost point, then I will have to use the height of the function at 2, 4, 6, and 8. If I want to use the rightmost point, then I will have the height at the rightmost point. The height at 4, 6, 8, and 10. For the left, the height at 2, 4, 6, and 8. For right, I start at the right, 4, 6, 8, and 10. You choose which one. We want to use the left or the right?
The left.
We want to use the left. Okay, in that case, I'm going to use this, and this, and this, and this only. So the area with left 4 is approximately, I have to have the base of each subinterval. Base is 2. 2, 2, 2 for all of them. So I will take 2 outside. F of 2 plus f of 4 plus f of 6 plus f of 8. Remember to have only 4. If you go to 10, there will be a mistake. 1, 2, 3, 4. Height at 2 times the base, plus height at 4 times the base, plus height at 6 times the base, plus height at 8 times the base. Exactly 4. Now, in the function, I have to plug in 2, 4, 6, and 8. Determine these numbers, and then multiply by 2. Okay, so f of x, clear, 0.01, 0.01 x to the fourth, and then minus 1.44 x squared, and then plus 60. and I want to plug in 2, 4, 6, 8. 2, 4, 6, 8. So 2 in front, and then 54.4 plus 39.52 plus 21.12 plus 8.8. Done. And now, I thought I had my calculator here. Just quickly, I have 2 parentheses 54.4 plus 39.52 plus 21.12 and plus 8.8. Done. So the area is 247.68. Any questions on this problem? Any questions? Is it clear how we got to 47.68?
Yes.
Perfect. Okay, I think I have a little